That skill presents decimal multiplication. There's something interesting about multiplying or dividing any number with a power of 10. Let's say you want to multiply the number 1234, just writing down 1, 2, 3, 4 in that order, 0.5678 times 10. The answer to this multiplication is going to be the same digits in that same order, only the decimal point moved one place over to the right. So the answer will be 12,345.678. And then when you multiply this number with 100, the decimal point moves two places over to the right. So we have 1, 2, 3, 4, 5, 6 times 7, 8. And when you multiply the same number with 1000, probably you guessed it right, move the decimal point three places over to the right. That makes it 1, 2, 3, 4, 5, 6, 7.8. And you do just the opposite when dividing this number with powers of 10. So if you were to divide 1, 2, 3, 4, 0.5678 with 10, the answer would be one place over to the left this time, the decimal point, 123 point, all the rest, 4, 5, 6, 7, 8. If you want to divide that with 100, you have two places over to the left, which makes it 12.345678, and so on. And just in case you're running out of digits in a multiplication or a division, you can feel free to add zeros, because zeros at the beginning of a number or at the end of a decimal number don't change the number. It's still the same number. For example, if you were to do, let's say, 1.6 times 100, you know that you need to move the decimal point two places over to the right because you're multiplying with 100, and it seems that there is only one digit. So what you do? Well, you just add 1 0 to the end. And you can do that. 1.6 is the same as 1.60. And therefore, once you move the decimal point two places over to the right, the answer is 160. Point what? 0, obviously. So it's the integer number 160. Similarly, if you are dividing, let's say, 8.7 with 1000, the decimal point should move three places over to the left, but we only have one place. We can always rewrite this as 008.7. It's still the same number. And therefore, if you move this three places over to the left, you have 0 point, the decimal point is over here. If there is nothing before the decimal point, it means there's a 0. So we have 0.0087. 0.087. And we could actually use the knowledge that we just gathered to multiply decimal numbers. Let's say you want to multiply the number 1.2 with the number 3.4. You can just treat this as a normal multiplication problem by ignoring the decimal points. Assume there is no decimal point in between the 1 and 2, and assume there is no decimal point between 3 and 4 as well. So this is pretty much the same as multiplying 12 with 34. 4 times 2 is 8. 4 times 1 is 4. Write a 0. 3 times 2 is 6. And 3 times 1 is 3. Add them up. You have a 8. 4 plus 6 is 10. Write down a 0. Carry a 1 over. 3 plus 1 is 4. Now this 408 that you see as the answer is actually the answer to the multiplication problem 12 times 34. So we know that 12 times 34 is equal to 408. But then how is 1.2 related to 12? The decimal point on 12 is right in the end because 12 means 12.0, And on 1.2, it's between the 1 and 2. Therefore, it's a shift of one place over to the left. This is how you have 1.2. And that's exactly what you have with 34 and 3.4. The decimal point is shifted one place over to the left. So that makes us conclude that 1.2 is nothing but 12 divided by 10. And 3.4 is nothing but 34 divided by 10. So if you multiply 12 with 34 and you get 408, to multiply 12 over 10 with 34 over 10, you divide that answer with 10 times 10, which is 100. Meaning, the decimal point on 408, which is right in the end, is shifted 2 places over to the left. So the answer is 4.08. And then how about trying to multiply, let's say, 0.12 with 3.4? Because we still have a 12 and a 34 here, the answer is still going to have a 408 in that order. But then 0.12 is 12 divided by 100 this time, 2 places over to the left, multiplied with 34 over 10. So that is equal to the product of 12 and 34, that's 408, divided with the product of 10 and 100, which is 1000. So this time, you want to move the decimal point 3 places over to the left. The answer is 0.408 or 0.408. Let's try a word problem now. If one donut costs 21.95 Rand, what is the cost of ordering 12 donuts? So it's all about multiplying these two numbers, 21.95 with 12. While multiplying, you just ignore the decimal point. 5 times 2 is 10. Carry the 1 over. 9 times 2 is 18 plus 1 is 19. Carry the 1 over. 2 times 1 is 2. 2 plus 1 is 3. And 2 times 2 is 4. 1 times 5 is 5. You write a 5 over here, starts with a 0. 1 times 9 is 9. 1 times 1 is 1. And 1 times 2 is 2. Time for us to add them up. We have a 0 here. 9 plus 5 is 14. Write down a 4, carry the 1 over. 9 plus 1 is 10. 10 plus 3 is 13. Write down a 3, carry the 1 over. 4 plus 1 plus 1 is 6. And we have a 2. So there you go. 26,340 is the product of 2,195 and 12. So the decimal point is shifted 2 places over to the left. No shift on the 12. It's still a 12. So this is divided with 100. And this is over 1. 100 times 1 is 100. So you have 26,340, but the decimal point is right in the end. It needs to be shifted 2 places over to the left. The answer is 263.40 or 263.4 Rand. Let's not forget the unit. So the cost of ordering 12 donuts is 263.40 Rand. You want to note that the number of digits after the decimal point on the answer is equal to the sum of the number of digits after the decimal point for the numbers that you multiply. So there were 2 digits after the decimal point on this one, no digit after 12, so you have 2 plus 0 is 2, so you have 2 digits after the decimal point on the answer. If we just go back to the previous problem we did, on this one, you have 2 digits after the decimal point on this one, 1 digit after the decimal point on this one, 2 plus 1 is 3, you have 3 digits after the decimal point on the answer. That's how multiplication of decimals work.